It's always best to learn with an example. One of the biggest decentralized applications out there allows unicorns to swap different currencies. For example, one unicorn might sell Ether and buy DAI token, and another one will do the opposite of selling DAI and buying Ether. So let's take a look at the website for this. You may have guessed it, we were talking about Uniswap. So here we can swap Ether for any other token. And if you're wondering, all these tokens here are actually a currency on top of the Ethereum blockchain. Those are called ERC20 tokens and are implemented as their own smart contract. We will actually implement one later in this course. So now, let's say I want to swap Ether for DAI. First, we have to connect our wallet. So, assuming you have MetaMask installed, we will choose MetaMask here. So, let's enter our password. And now first you see here, we are connected to the Ethereum mainnet. As we already said, MetaMask is using the Infura service under the hood. And this network will determine to which node our transaction will be sent to. But theoretically, you could use any other service, not Infura, or even run your own node and connect MetaMask by adding your own network here. Not only relying on Infura is also better for decentralization. So this heavy dependence at the moment is certainly not great. So I would actually encourage you to look at Infura alternatives or even run your own node. But for now, let's use the default configuration. The Ethereum mainnet here is where the true value is stored. But for us developers, there are also some test nets. So we can test things without having to pay real money. So let's just switch here, for example, to Rinkeby. You can see I already have some Ether on this network, but you can easily get this for testnets. That's the whole point of a testnet after all, right? The funds don't have any value, and to get the funds you can use faucets. For example, here would be a faucet for the Rinkeby testnet. You can read the instructions here on how to get your funds. Or you may even use a multi-faucet like this. Here you can enter an address and then receive funds for multiple different testnets at once. But make sure the network you need is actually filled. You can see here some networks, including Rinkeby, are currently empty, so just double check that. Okay, so now we can trade DAI. But remember, this is DAI on the Rinkeby testnet. So just a test token with no real value. And let's say we want to sell 1 Ether. So usually this would give you roughly the amount in DAI that 1 Ether is worth in US dollar, since 1 DAI is always 1 US dollar. But we are on a testnet here, so the value can be different. Like you can see here now, we would receive much more in DAI than what 1 Ether is worth in US dollar. So now let's swap. This will open MetaMask to ask us to sign the transaction. We can take a look at the details. This is the amount of Ether we are sending, 1 full Ether. Here you can see where we are sending the transaction to, which is the Uniswap smart contract address on the Rinkeby testnet. And now here see the estimated gas fee. You can manually adjust it by clicking edit. So let's go to advanced options. And gas limit here is the parameter that tells the network you don't want to spend more than this amount of gas. This is if you remember to avoid infinite loops and to just generally give you control over how much gas is used. If you are just a user, the wallet will automatically fill this by looking at the smart contract function and simulating the call. So generally, you don't need to change this. And now at the bottom is essentially the gas price. Because we are operating on a testnet, there's no real value behind Ether. And so the gas price here has no real meaning. On mainnet node, this value here will exactly determine how much you end up paying as a transaction fee. And then this priority fee here is for the EIP 1559 transaction types. It says how much of the fee should go towards the miners, which may speed up your transaction confirmation a little bit. And then here under hex, we can see which function is called and the raw data. As you can see, it's not really that user-friendly yet, but it will be something that in the future will probably change. And rather than seeing raw data, you might end up seeing a more descriptive form of what the transaction is doing. So now let's confirm the transaction to send it. Now you see we have a pending transaction here in MetaMask. And when it's confirmed, we get a notification. And now you see we have indeed received the new token in our wallet.